Okay, we are going to talk about when to use law of sines and when to use law of cosines, just to make sure we all understand. So I've drawn the pictures, just a generic non-right triangle picture that goes with all of these, and I labeled all the sides correctly. So let's highlight what each of these are talking about. So AAS, that would be if I'm given an angle, highlight, an angle, the next angle, and then a side afterwards, right, going around the triangle. Well, if those highlights are the information I'm given, then I clearly have a full law of sines ratio, so I want to do law of sines. ASA, you're given an angle, the side in between them, and then another angle. So this one's a little deceiving, right? Because it looks like I don't have a full ratio. I don't have those, I don't have those, you get the idea. But if you have two angles, you automatically have the third angle, right? Do a little bit of triangle sum and you have that third angle, and now you have a full ratio to do law of sines. Side-side angle, you're given a side, the next side, and then an angle afterwards. You end up with a full sine ratio. The other options, side, 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 clearly I don't have a full sine ratio, so I'm going to have to do cosine. Side, angle, side, again, I don't have a full sine ratio, so I have to do law of cosines. Hopefully you guys are catching on to that okay. So let's do some examples. Highly recommended for this video, because we have done this together now in video and in class by now. You should just pause it and do this one all by yourself. I'm going to talk you through it, but I highly recommend you pause it and try it on your own. Okay, so I did go ahead and draw the picture. So you guys should be able to look at this and decide if it's law of sines or law of cosines. Based on the ones I have a full partnership for law of sines, a full sine ratio. So this should be a law of sines. And potentially there could be two triangles, right? So I'm going to stay on the left side and I'm going to set up a law of sines. Cross multiply. You should pause this video at any chance you get and see if you can finish solving for A. Type that into a calculator, and for A1 I get approximately 76.411, and I'm going to store that in button A. Now that we have two angles, right, because there was one in the problem and now we just found that one, now we can find the other angle, which is angle C, by doing 180 minus the 63 that's given and minus A that we just found. So if you type that carefully into a calculator, angle C1 ends up being approximately 40.589, rounded to 3 decimal places. Store that in B. And then you're going to need to do a law of sines to get lowercase c. So I can't split my paper perfectly in this one, so I'm going to go back up to the top. Stick with the sine of 63 over 11. And we stored that in B, so we're going to do sine of button B over lowercase c. Pause it and see if you can finish solving for C. Okay, so I didn't show my cross multiplying or dividing, but hopefully you could follow along, and C1 is 8.032. Might as well do the area while we're at it. Area of triangle 1 is going to be, I like to use the sides that were given, so 1/2, 11 times 12 times sine. It's angle C, but we stored angle C in button B. So if you haven't yet, find the area, approximately. Make sure you're putting these answers in the right answer blanks, right? I can't give you credit if you don't know what you're finding. Okay, then the second half. To find the first angle that we can find, we look at the first angle we found originally. We found A1, so we're going to find A2 by doing supplementary, 180 minus A1, which we stored in button A. If you do that, 180 minus button A is going to give me 103.589. Now, it could exist, it might not, so I better store that. I don't know it exists until I do the next step. Again, on the other side. To get C1, so to get C2, you do triangle sum. 180 minus the 63 in the picture, minus potentially angle A2, which is in button C. Keep track of your buttons. And angle C2 comes out to be 13.411, which is not negative, so this does exist. 13.411 for C2 and 103.589 for A2. So I don't know until I get here. If this is negative, it does not exist. Since it was positive, we keep going. So I've done the first two steps on the left. Now I'm on this step, but obviously we need to use our new numbers. So sine of 63 over 11 did not change. Sine angle C. Oh, did we save it? Sorry, go back and save it. Hopefully you haven't pressed anything on your calculator. Save angle C and button D. Now, angle C is button D over little c. See if you can finish this. Find little c2 and area 2. Okay, there are my answers. Cross multiplied, C is 2.863, rounded correctly. That was C2. And area is 15.308. So hopefully you're starting to catch on to the points, to the steps, I should say, on how to solve law of sines, including the ambiguous case, including that extra triangle. Example 2, set up the picture, figure out which law we're going to use. Okay, so based on my picture, I do not have a full ratio, and I do not have two angles, so I can't even find another angle. So you have no choice but to do law of cosine. See if you can set up your equation for law of cosine. Based on the angle we have, we only have one choice as far as what side we try to find first. So here is my equation. Also, remember in adding, the order doesn't matter. Also in multiplying, the order doesn't matter. So what I'm trying to say is if you have 11 squared plus 12 squared there, doesn't matter. If you have 11 times 12 there, doesn't matter. So don't worry about that. See if you can solve this. It's just a quick square root problem in your calculator. I did take a shortcut and just say b is going to equal to the square root of all the above. Please do not do that on your test. But when you square root that whole equation all at once, carefully typed in, you should get 12.048. Also, while I'm at it, this is a law of cosines problem, so all of the second triangle answer blanks do not exist. Don't forget to answer that. You still must tell me you know they don't exist, not just you forgot to try to find them. Okay, so now we know lowercase b. Save it in button A. Technically, you can save it wherever you want, but if you want your notes to match mine, right, as I'm talking, you want to save it in button A. Now I could choose either angle to work on next. I'm going to choose lowercase. How about capital, because it's an angle? I'm going to choose A. So if I'm starting to find angle A, I need to use the 12 to start my equation. See if you can write your equation to help us solve for angle A. Okay, so check your equation, remembering the order you add and the order you multiply doesn't matter. Then see if you can move it all over. I'm going to get all the way down to cosine A equals. See if you can get cosine A alone. Okay, I didn't show my work, but I minus the 11 squared over, and minus the A squared over, and I divided by negative 2 times 11 times A. Then inverse cosine. So angle A is going to be cosine inverse, and this is where the parentheses really matter. Parentheses on the top. Close the top, press divided by, parentheses on the bottom, negative symbol. Technically, it doesn't matter if you close the parentheses because that's the last thing you're doing. And you should get angle A to be approximately 62.558. And you should store that. Might as well store it in B. Now that we have two of our three angles, you can do triangle sum to find the missing one. You're welcome to do law of cosine again, but angle C is going to be 180 minus angle B, which we knew, and minus angle A, which we just found. So approximately 54.442. And then lastly, area. See if you can find the area. See if you can figure out which numbers I'm going to use to be sure I get it right. So whenever possible, use the numbers that were typed on the test. So 1/2 is the formula. I don't know why I put a colon, that should be equals, right? 1/2 side times sine, the angle in between. So all of those numbers were given on the test. So I'm almost guaranteed to get this right as long as I type it in my calculator correctly and as long as my calculator is in the right mode. 58.806. Okay, now that we know law of sines and law of cosines, we can do navigation word problems. There's a couple things at the top about navigation. True distance is the distance you end from where you started. So it's not following your path. It's literally how far are you away, a straight line, if you could swim or fly, whatever we're talking about, in a straight line, how far are you from where you began? And then bearing is the direction from where you started to where you finished. So here's the thing about bearing. Bearing always needs to be an acute angle that touches north or south. Bearing. Acute, so less than 90, angle that touches north or south. Also super important for this piece, you need to know a compass. So if you don't know a compass yet, north, south, we live on the west coast, east. So make sure you know how a compass is laid out, or these problems are really going to be a struggle. So let's see if we can draw a picture for what's happening here. Read it to yourself first. And then as I draw these, I want to think about where to start my picture, right? I don't want my picture to go off the paper. So I see that I'm going to be heading west. So I need to be far enough east that I can head west. And then I'm going to be heading northwest. So I need to be far enough east and far enough south. You'll get better at these as we go, but so I don't know. Depends on how big your picture is going to be. Maybe right here is a good spot to start. And you start with a tiny compass. You don't need to label it north, south, east, west. But that right there is supposed to represent a tiny compass for my problem. Now I'm going to draw what my boat does. My ship leaves port heading due west. That means literally on the west line, you go straight west for some amount of time. Just so you know, these are never to scale, right? I'm not going to count out how many blocks it needs to go. Then you draw a new compass at where you are currently, because you need a compass every time to know which way you're going. Then, so that was 16 knots, and we'll put that in there in a minute, but then it changes course to northwest, north 37 degrees west. So northwest, and then the 37 degrees has to touch north and your orange line, right? If you can see my colors, it touches north and the orange line. This is 37 degrees. A bearing always touches north or south. And then that's where my boat ship stops. And I need to find a bunch of things compared to port. And actually, I should name this port because they get confusing later. You don't remember where your boat started. That was port. And one of the things they want us to find is the distance from where my boat stopped to port. So that red X is going to be the first thing we find. It's also asking for the bearing, and I will get to that later, but you will always find the red X first. One of the nice things about these problems is that it is always the same process to get the numbers, but there might be some changes along the way, and I'll point those out as we go as well. So let's put some measurements on our distances. So 16 knots, that's nautical miles per hour, so it's just a speed. From 3 until 6. So from 3 until 6 is 3 hours. 16 basically miles per hour for 3 hours. 16 times 3, this length is 48. You went 40 nautical miles in that amount of time. Then you change direction at 6 o'clock. Remember, you change direction at 6 o'clock. You're going 14 miles per hour until 8 o'clock. So from 6 to 8, that's 2 hours, times the speed, 14, that's going to be 28. That's a length of 28. The last thing we need is the angle opposite of the red X. So we're going to need this angle. It's not always the same math to get that angle, so I don't want you to think just because you've done one problem, you always know how to find that angle. But in this picture, from the bottom right, I go past north, right? So this is 90 degrees, and then I go 37 more degrees. So in this problem, we can add them together to get 127 degrees. Now, if you know nothing else about the word problem, look at the picture. Can you solve for x? Is it law of sines or law of cosines? So I do not have any perfect sine ratios, so it has to be law of cosine. We are solving for x, so see if you can write the equation to help us solve for x using law of cosines. Okay, there's my equation. Make sure you understand why and where it all came from, and then solve it. Get x, and then of course we're going to need to store it for later. X is the distance. From where you started, you are now 68.598 nautical miles from where you started. I'm not going to worry about units. Okay, now we need to worry about bearing. For bearing, a bearing either touches north or south, and it has to be the acute angle. You can't always go by your picture, but because this one was due west, true west, whatever, due west, it's pretty likely that our picture is correct. But what we're going to need to check is this angle, I'm going to call that alpha, is that angle acute? Or, because it touches north, or is this one from south to our red line? Always to your red line. Is that one going to be acute? I'll call that one beta. But I'm actually going to get rid of that one because clearly you can see in this one the alpha is going to be the acute angle. So that's the angle I'm going to use for my bearing. But before I can do that, I have to find theta, which I'm adding to my picture now, inside the triangle at port. And this will always be, I'm going to call it your second step, right? First, you'll find x, the red line, and then you will always find that green theta inside your triangle at port. And this is just back to a law of cosines problem. So if I'm working on finding green theta, set up a law of cosines problem to solve for that. Why don't you finish it? Set up a law of cosines, so 28 squared equals, there's a hint, and then finish it for me. Find theta. Okay, so hopefully you can follow what I did, or you already did it. Theta ends up being 19.025, just following law of cosines. And then I needed to store that, because that is not the answer. Almost never is theta actually the answer. What you have to do from there varies by word problem, right? It varies by picture. So you can't just say, oh, well, last time I did this, so this time I'm going to do the same thing. You need to look at your picture. So we know theta is 19-ish, right? So if you look at your picture, I'm going to switch to, I don't know, this weird pink color. If theta is 19 and I know this much is 90, right? Because it's a quadrant. From north to west is 90 degrees, then this time alpha should equal 90 minus my theta, or 90 minus button B, if that's where you stored button B. So alpha, which is actually part of my bearing, is 70.975. Then you have to look at your picture. Where did you start? Sorry, not where did you start. Which direction are you going? So my blue alpha, right? My original blue alpha, this is my blue number, touched north and it went west. So this is north, 70.975 degrees to the west. This is our first navigation example. See if you can set this one up. So start by looking at what direction am I heading so that you leave yourself enough paper to set up the pictures. So I'm going to go southeast, which is down and right, and then I'm going to go northeast, which is up and right. So I need to start on the left, right? I need to have enough room to do everything I just said. Start with the compass, and let's label it port before we forget. Okay, the first thing this ship does is goes south 19 degrees east. So from south to east, so this way, the angle touches south and that new orange line. So in here is 19. Then it's going to change course. So you set up a new set of compasses, a new compass, I should say. So we can set it up. Try to make your compass touch your line. And then it switches to north 72 degrees east. So from the north line, it's going to go 72 degrees towards east. From north, 72 degrees towards east. That's where it ends. You connect it to your port. That red line is your first x. But we're going to need to find some angles in order to be able to solve for x, right? You always need the angle opposite x if you're going to do, here's a hint, it's always law of cosine, right? So this is where those angle properties we reviewed come into play. So this compass north-south line is parallel to this compass north-south line. And then this orange line is a transversal going through two parallel lines. So if you know this angle was 19 degrees, alternate interior puts this angle being 19 degrees as well. So you're going to need to remember some of your angle properties. Then together, 19 and 72 gives me 91 degrees. Now, well, no, we didn't put the side measurements on yet, sorry. So now you have your angles. See if you can figure out your sides. How long were you driving and at what speed? So 18 miles per hour from noon to 4. So 4 hours at 18, 4 times 18 is 72. Then from 4 p.m. till 6:30, so 2.5 hours at 14. 14 times 2.5 is 35. Now you have enough to solve for x. This is what, our third cosine problem in just this video. So please solve for x on your own. Pause your video. Okay, hopefully you get 80.604. You can see my setup, and then hopefully you can follow what I did after that. Okay, then I said you will always find theta inside your triangle by port. So inside my triangle, between the red and the orange, by port, this theta is what you always find next. Even if you don't understand the word problem, you should all be able to find that green theta. You have enough information. Find green theta for me. Pause your video. Okay, hope you're getting better at that. Angle theta should end up being 25.732 degrees, and I stored it in button B. Remember, theta is not always the answer to bearing. In fact, I even said it's never the answer to bearing. We need to look at our picture. So you have two options. I'm switching to this tealish color. From north to the red line might be the acute angle, or from south to the red line might be the acute angle. Only the one that's acute gets to be the bearing. So it looks like south to the red line is going to be the easiest one to find, right? I'll call it alpha again. Alpha is going to be 19 plus theta, which is in button B. If you add 19 to button B, you get 44.732, which is an acute angle. It's less than 90, so that's the answer. If I did that and it was an obtuse angle, right, bigger than 90, then I would have to go the other way and go from north to the red line. But since this is acute, the red line starts at south. That's what I connected my alpha to. And it goes 44.732 degrees towards the east. So hopefully this is starting to make a little sense, and I hope you guys are doing good.